Doing June 2021. We're going to do a work-through video, and I've got codename D here, who's going to help me out, going to ask some questions, and hopefully it's going to answer some of the questions as we work through. A little bit of a collaborative affair. Okay, so let's begin. Write your answers in the D1 answer book. So I've put part of the answer book to the right here, so you will be able to see how we write out the answers and the questions. First thing, calculate the lower bound. So to find the lower bound, we first have to find the sum of all of the values, and if you add them all together, you get 177. And it tells you that the containers can hold a maximum weight of 45, so how many do we need? What do we get? 177 over 45 is 3.933. Very good. So do we say that the answer is 3, 4, 3.933? How do we choose?
4, you go to the next number.
You go to the next number. Why is that?
Because 3.9 is obviously the container cannot have 3.9, so it has to be more
so what kind of a value would you say the number of containers is? How do we define it?
Integer.
It's an integer, right?
Yeah.
So 3.9 is between 3 and 4. 3 containers would not be enough because there's more than 3. So we would need 4 containers, and that's the lower bound. Okay, moving on to part B. So we're asked to do first fit bin packing. Okay, so as we read from right to left, as we normally do in English, we assign from, not right to left to right, we assign from left to right. And each of our bins must have a maximum amount of 45. So what I'm going to do is I'm going to set up 5 bins. I know that the lower bound is 4, but I'm going to assuming that we might not hit the lower bound because that's pretty close to 4. We don't have a lot of give. We probably will need 5, maybe more, but I've set up my 5 bins, right? And the maximum value of each bin, the maximum value, the top value of each bin, we know is 45. So in order to make sure that I don't make a mistake, I'm going to have a running tally underneath. And I'm going to tick off these values. So first up, we're going to put 16, the first available bin. 16. Our running tally underneath is 16. Then 23. So if you put 23 in here, that's going to make 39. So my running tally is now 39. That means that since my max is 45, I have to add, what's the maximum I can add to my first bin? 6. Do we have a value under 6? Our first available is 4. So that I know is going to go in there. So I don't need to worry about bin 1 until there. 18 will go in bin 2. 9 will go in bin 2. Gives us a total of 27. 4 will go in bin 1 because it will now fit. So that will now go up to 43. 20, will it fit in bin 2? No, because that gives us a total of 47. So that will have to go in bin 3. What about 35?
It wouldn't fit in any of them.
It doesn't fit, so we have to start a new one.
Yeah, bin 4.
Yeah. What about 5? Does that go in bin 4?
No.
Bin 3?
No.
Bin 2, yeah, you got it. So we add our 5 there, and that's going to give us 32. Now, going back to bin 1 has a maximum of 45, and there's 43 in it. There are no values too, so I don't need to think about bin 1 anymore, because I know that no other values will be added to it. So, where are we at? 17. Will 17 fit in bin 2?
No.
So we'll put it in bin 3, which gives us 37 as our running total. 13, will it fit in either?
Yes.
Which one?
Bin 2.
So 13 goes in bin 2, giving us a maximum of 45. So this bin is sealed, this bin is sealed. Now we've just got 6 and 11. 6, will it go into bin 3?
Yes.
which gives us
43.
and that we know is sealed. And 11, will it go into bin 4?
No.
Oh no, so close. 46. Maybe we can just squeeze it in. Nope, none of that stuff. So that's going to take us 5 bins. So our first bin has 16, 23 and 4. The order matters. If your numbers aren't in the right order and they can't be seen to be in the right order, then you don't get the marks. 18, 9, 5, 13. So I'm checking along the mark scheme, which I've got on a different screen. 20, 17, 6, 35 and 11. So that's a M1, A1, A1. M1 for getting the first couple of bins right, and then A1 for getting, identify the 20 and the 35, and then the final one is to get a perfect answer. So 3 easy marks. Okay. Do you have any questions on that, D?
No.
Awesome. I'm just going to shrink that down a little. Next, carry out a bubble sort. Oh, this is going to be boring. Starting on the left-hand list to produce a list of the weights in descending order. Okay, let's do this. All right. So our numbers are, and we only have to do the full kind of like run, not each value. So 16, 23, 18, 9, 4, 20, 35, 5, 17, 13, 6, 11. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data that we need to sort. What's the maximum number of swaps for 12 pieces of data?
12, 13.
If I had 2 numbers and I wanted to get in ascending order, what's the maximum number of swaps?
1.
1. 2 numbers, it's 1. What about 3 numbers?
2.
Right, so it's always 1 less than number per run. So if I wanted, what is the absolutely worst solution? And there are questions that ask this, so it's good to know. It's going to be, well, the worst for 12 pieces of data is 11 swaps. And then you have at least one piece sorted. What about next?
10.
And then? Yeah, and so on to on. So to find out the worst situation, that would be it. And the minimum number of swaps is 0 if your data is already sorted. Then don't need to do any swaps. If we're looking at our data, we've got some big values in the middle, some small values in the middle. There's going to be a little bit of work to be done. So we're sorting this in descending order. In order to remind me of this, I'm going to do an arrow on the left to show that I'm going from a high value to a low value. So whenever I compare, I want to put a high value to the left. So on my first pass, the 23, do I swap?
Yes.
Now I don't write the 16, but I know there's a 16 here. 16 and 18, do I swap?
Yes.
I write the results of that. Now with the 16s here, 16 and 9, do I swap?
No.
So I write the 16 down. 9 and 4, do I swap?
No.
4 and 20, do I swap?
No.
Big number on the left.
Yes.
Yes. So now my 4 is here. 4 and 35, do I swap?
Yes.
4 and 5, do I swap?
Yes.
4 and 17, do I swap?
Yes.
4 and 13, do I swap?
Yes.
4 and 6, do I swap?
Yes.
4 and 11, do I swap?
Yes.
So you notice that it's taken this 4 and delivered it. That's the absolutely worst thing that can happen. The worst result is that one number gets in the right place. The best result is 2 or 3 or 4. But the worst result is one number gets sorted. Remember I said there's 12 data, so 11 swaps. Yeah? Imagine the 4 was over here. Then there would be exactly 11 swaps to get it there, right?
Yeah.
Any questions on that?
No.
Okay, cool. So, Starting again, second row. Remember, we want bigger number on the left. 2318.
No.
That's good. 1816.
No.
169.
No.
920.
Yes.
935.
Yes.
95.
No.
517.
Yes.
513.
Yes.
56.
Yes.
511.
Yes.
54.
No.
Okay. Now let's run again. Let's make this quick. 2318.
No.
1816.
No.
1620.
Yes.
1635.
Yes.
169.
No. 917.
917.
No. Yes.
913.
Yes.
96.
No.
611.
Yes.
And 654. So we know that 654 is now fixed. We just need to get this 9 over here, and then a lot of this is going to be a lot neater. So hopefully it won't take us too many passes. 2318.
No.
2018. 1820. Yes.
Yes.
1835.
Yes.
So you see the 35 is slowly sneaking its way to the front. 1816.
No.
1617.
Yes.
1613.
No.
139.
No.
911.
Yes.
And then 9 will go here. 6, 5,
5,
4. So you can see that our data now is sorted all the way up to here. Yeah?
Yeah.
We just need to sort out these 3. So let's have a look at that. 2320.
No.
2035.
Yes.
So 35 and 20. 2335.
Yes.
2320.
No.
Okay. And then the rest of our data is just exactly the same, 18 all the way down to 4. And then we do it again one last time. Why do we do it again one last time?
To show that there's no other pass.
Yeah, because, you know, we must do one extra pass at the end to make sure that's a confirm and that no other pieces of data need to be sorted. And our data is now sorted. They have a grid of values that will kind of maybe go over the top of this. If any of your numbers are wrong, they will flag. You'll be allowed a certain amount of errors. I think you can get 1 follow-through mark and 1 method mark, so you need to know. And then we'll work from there. Hang on, I just need to restart the app. There we go. All right. So let's just shrink that one down, and that is now sorted. Can you guess what we're going to do next? Yeah, we're going to, now that we have it in decreasing order, we're going to do the bin packing again. It's a very standard question, so this is part D. So we follow the same process. Now I'm going to guess that they're trying to teach us a lesson. What do you think the lesson is they're trying to teach us?
I don't know actually.
Well, at the start, how many bins did it take?
5.
Then what did we do to the data?
We arranged it in descending order.
So what do you think the lesson is they're going to teach us?
I have to start with big to have lesser bins.
If you sort it in order,
Yeah.
what do you think that's going to do to
Reduce the bins.
reduce the bins? That's a lesson, right?
Yeah.
So I'm going to guess that since that we needed 5 bins here, the lesson they're going to teach us is that there's only going to be 4 bins needed. It might not be the case, but that's my guess. Okay, so we're doing it with that data. Shall we begin?
Yeah.
35.
First.
Yep, 35. 23. Does it go in the first one?
No, second.
Second one. Okay, 20.
Third one.
Are you sure?
No.
Don't make assumptions, yeah?
Yeah.
It's very easy to make a mistake on this and lose marks. Check your work. Now, is there anything lower than 2 or lower in our data?
No.
No. So I know that this bin is full. I don't need to check it again. Reduce it from your question. So that's 20 sorted. 18, will it go in the first one?
No.
What value do I need in the first one?
10.
10. So I only need to consider the 9. So I need to be aware that this is going to go in bin number 1, right?
Yes.
Now I'm just going to be working down here because I know that bin 1 is waiting for the 9. Bin 2 is full as far as we can get. So 18 will go in here.
Yes.
That's my running total. What's next?
17.
Will it fit in there?
Yes.
What's my total now?
35.
35. What about 16? Will it go in there?
No.
Because that's the same size. They're both waiting for 9 or 10 or below. So our 16 will go over here. Our 13 will also go over here, giving us a total of 29. 16 and 13. So 11.
To go the last one.
Yeah. Now, let's see if we can fit the rest. Where will 9 go?
First bin.
It must be in the first available bin. Where will 6 go?
The third bin.
That's 41. Where will 5 go?
The last bin.
Very good, which gives us a full bin of 45. And where will 4 go?
Third bin.
Third bin, 45. So it's a really efficient solution here because we've got 2 bins looking at maximum efficiency. One is just 1 short, one is just 2 short. It's an effective solution. The lesson that they're teaching us, that when you arrange them in ascending or descending order, then it improves the algorithm and makes it less computation involved. So doing that extra step. Okay, question 1 over. Question 2. One project is modeled as a network above. The networks are represented by arcs. The number in brackets on each arc gives the time in hours. So just bear that in mind, time in hours, all right? Each activity requires 1 worker. The project is completed in the shortest possible time. Complete diagram on in the answer book to early and late times. Easy peasy. Do you want to do this or do you want to power through it?
Power through it.
Oh, D. Okay, so what do we write in our start node?
0, 0.
No tasks have started yet. So then we write our 3 options. So 0 plus 3 is 3. Remember, when there's multiple ways in, which one do we pick?
The biggest.
We pick the largest going forward. And when we're going backwards, if there's multiple ways, sorry, let me put that another way. If there are multiple ways backwards into a box, we pick the smallest. That's the key thing to remember. Biggest going forward, backwards, smallest going backwards. So 0 plus 2 is 2. We're only looking at the top boxes now. So what do I write here, D?
4. No, you wait
Ooh, right. How many ways are there into this box?
3.
Okay, so which one are we going to pick? The largest. So 3 plus 0 is
3.
4 is 4. 2 plus 5 is
7.
So which one's the largest?
7.
Yeah, you see how easy it is to make a mistake?
Yeah.
Okay, so now we need to look at the boxes that we know all of the ways in. Do we know all of the ways into this box?
Yes.
We know I, we know H. Do we know this? Do we know this value?
No.
No, so we cannot work out this box. Do we know all the ways into this one?
Yes.
Yeah, we do. Do we know all the ways into this one?
No.
1, 2, no, we don't know this one. So you see how that helps us determine which box we're filling in. So we have to do this. We're at week 7 and we spend, hour 7 and we spend 7 more hours. We're at hour number 14. Now we can do these top and bottom values. So 14 plus 0, 7 plus 6 and 2 plus 4, which is the biggest?
14.
Well done. 14 plus 0, 7 plus 2 and 3 plus 5, which is the largest?
14.
Okay. So, do we have all the ways into this one?
No.
How many ways are there into this box?
No. Yes,
Well,
we have.
yeah, we do. Right. So 14 plus 6 is
20.
20. Do we have all the ways into this box?
No.
Ah, very good. Do we have all the ways into this box now?
Yes.
Yeah, we do. So 14 plus 7 is
21.
14 plus 4 is
18.
14 plus 8 is
22.
22. So what do we write?
24.
You fell for me. I thought you were going to 5 one time. I wasn't going to ask you that. I want to see if you realize 20 plus 4 is 24. Look at you. And the last one, 24 plus 4 is 28, and 14 plus 8 is 22. So the answer is
28.
28. So since this is our final node, we also write 28 on the bottom. Now we need to look at the reverses. Now we have 2 ways back from here. We can go 28 minus 8. Do we go this way back to follow Q backwards?
No.
We don't have all of the roots backwards. We don't have the bottom number here. What about here? Do we have all the roots back into this? These are roads in. There's only one road out, so we can do that. 28 minus 4 is 24. What does that tell you about that node?
There's no
That
float.
path.
So it's
There's no
critical.
float, so it's critical, right? Because 28 minus 4 is 24. When you see the same number on top and bottom, does that mean it's critical?
No.
Not necessarily. Very good. Okay. You're looking for the subtraction to work, not the numbers to be the same. Usually the numbers are the same indicates, but not always, so don't use that as an assumption. Do we have all the ways back into this node?
Yes.
There's only one way back, so 24, lower number, minus 4 is
20.
20. Okay, so what can we say? This is also going to be part of our...
Critical.
Okay. And, first interesting question. How many ways back into this box?
2.
So what are our 2 options?
20 minus 6 and 24 minus 8.
So what's 20 minus 6?
14.
And 24 minus 8?
22.
24 minus 8? Okay. No,
16.
no shame. 16 and 14, but when we're going backwards, we pick the...
Smallest.
So we pick 14. Okay, what about this bottom one? Do we have all the ways back into here?
Yes.
Yeah, so 24 minus 7 is...
17.
And 28 minus 8 is 20. So 17 or 20, what do we write?
17.
Okay, and what about here? Do we have all the ways back into here? How many ways are there back into this?
2. Wait, 1. 3.
3, right. So 14 minus 0 is...
14.
I'm not going to get less than 14. I know it's going to be 14, but I still do the maths anyway. What's 24 minus 4?
20.
And what's 17 minus nothing?
17.
So 14, 20, and 17. 14 is the lowest. Okay, so where do you want to go next? Can we do this one?
No, you need...
We need the middle. Can we
Yes.
do this one?
No, you need
No,
the middle.
we've only got this way backwards, I. So here, what are our options?
17 minus 6
Yep.
and 14 minus 7.
And
7 is the smallest.
so we've got 14 minus 2 as well. You didn't mention that.
14 minus
14 minus 2 is 12. 14 minus 7 is 7. 17 minus 6 is 11. So 7 is the smallest. Now we can do these two. What are the options here?
7 minus 0 and 14 minus 5.
Which is the smallest?
7 minus 0.
7 minus 0 is?
7.
And
We have 2 options, 7 minus 5 and 17 minus 4.
what's the lowest?
7 minus 5,
Which is?
2.
Okay, so now let's highlight our critical path. So
C.
C. So do you remember I told you that just because a path links to critical nodes doesn't mean it's a critical path. So B connects 0, 0 to 7, 7, but it's not on the critical path. Because 7 minus 4 is not 0. So then we go up here to 7, 7. Then which one is the correct path? F or G?
G.
Because?
14 minus 7 minus 7 is 0.
Good. And then 14 minus 0 is 14. And then which way do we go? There's again 2 paths, so we have to be careful.
J.
14 plus 6 is 20. 20 plus 4 is 24. And 24 plus 4 is 28. So our critical path is, oh no. Okay, let's see what we can do about that. Oh no, everything's a little bit weird. Okay, cool. Oh, it didn't screenshot it properly. Oh well, weird. All right, let's write it on. What did we say? We said 7, 7, 2, 14, 14, 17, 20, 24, 28, is that right?
Yeah.
Let's get that path on again. Remember, you can use highlighter in your question paper, but not in your answer books. Okay, so what's our path? It's going to be C, E, G, J, and P. Okay. All right, so now we need to fill in our thing. Let's put these numbers on here. So C was 2, E is 5, G is 7, J is 6, N is 4, P is 4. Okay. So C is 2, E is 5, G is 7, J is 6, N is 4, and P is 4. So we write the letters now: C, E, G, J, N, P. Now, the next piece of advice I have is to work on your alphabet. So all of these steps are A, B, C, D, E, F, G, H, I, J, K, L, M, N, M, N. There's no O, P, and Q. So we're going down to Q. So I'm going to write all of those letters down one by one because this is our Gantt chart, right? Is there an A up here?
No.
So we have an A. Is there a B?
Yes.
No. On my critical path? No.
No.
Is there a C?
Yes.
Is there a D?
No.
Is there an E?
Yes.
Is there an F?
No.
Is there a G?
Yes.
Is there a H?
No.
Is there an I?
No.
Is there a J?
Yes.
Is there a K?
No.
Is there an L?
No.
Is there an M?
No.
Is there an N?
Yes.
Is there an O? No need. Is there a P?
Yes.
And then final one is Q. So once you get the letters down, then you know exactly how many rows you're dealing with. Yeah? Okay, and then, okay, so what is task A? So A has a duration of 3 and a float of 7 minus 3 is float of 4. So what I'm going to do is the durations I'm going to do in yellow, and the float I'm going to do in blue. So A starts at 0 and has a duration of 3 and a float of 4. Does that make sense?
Yes.
Okay, B can start at 0, has a duration of 4 and a float of 3. Okay. C we've got, so let me cross them off as we do them as well. A, B, okay, C is there, D. D can start at what time?
3,
Has a duration of,
5,
and what's the float?
6,
14 minus 5
5
minus
minus
3, 6. So it starts at 3, duration 5.
float 6,
So starts at 3, duration 5, so that's 8, and its float is 6 more, so that will take us up to 14. Okay. So that's D done. F is next, which starts at
7,
and has a duration
Duration
of
of
2. Starts at 7, has a duration of 2, and a float of
5.
5.
Can we have a score for the next 2 hours? Oh.
9 plus 5 is 14. Yeah? And we can check that on here. What's the end time of F, the last end time? 14. Okay, so that's F done. G is on, so H starts at 7,
Duration of 6.
duration of 6. So it also starts at 7, duration of 6 will make it go to 13. And what's the float?
4.
17 minus 7 minus 6. No, what's the float?
17 minus 7 minus 6, 4.
What's 17 minus 7 minus 6?
4.
What's 17 minus 7 minus 6? Yeah, it is 4. You're right. I'm wrong. I'm not quite sure where my brain was then. So the float is 4, so we add 4 more. So that's week 17, which is correct at the end point. Okay, so that's H. What's next?
I.
I. When does I start?
2,
And has a duration of,
4,
and then what's the float?
11.
Oh wow, massive float. Lots of options there. So that's 6 plus 11 is 17, right? Okay, nearly there. K starts 14, has a duration 8.
And float of 2.
Start 14, duration 8, and a float of 2. L
Starts at 14, duration 4, and float 6.
okay. K, L. Now it's just M and Q. So M starts at 14.
Duration of 7, and float of 3.
M starts at 14. Duration of 7, so 21. And what was the float?
3.
And finally,
Q starts at 14, duration of 8, and float 6.
okay, and there we have it. A lot of time spent on that question. It does take time, but that's one of the things you're going to have to manage. Okay, last part, 2 marks. Use your cascade chart to determine the minimum number of workers to complete in the shortest possible time. So the key thing you need to look at here is how many workers do we have working at the same time. Now, if we look, so I'm going to do something a little bit different now. What I'm going to do is I'm going to take each of these nodes and move them to the opposite side the latest possible they could do. Okay. So A has a duration of 4, so I could go back 4. 1, 2, 3, 4. B has a duration of 5, I'm going back 5. 3, 4, 5. This has a duration of 5, I'm going back 2, 4, 5. This has a duration of 2, I'm going back 2. This has a duration of 2, 4, 6, so I'm going back 2, 4, 6. This has a duration of, I has a duration of 4, so I'm going back for 1, 2, 3, 4. This has a duration of 2, 4, 6, 8. 2, 4, 6, 8. This has a duration of 5, so I'm going back 5. Here we have a duration of 2, 4, 6, 7, so 1, 2, 3, 4, 5, 6, 7. Here we have a duration of 2, 4, 6, 7. Let's go back 7, 2, 3, 4, 5, 6, 7. So what I'm looking for is this shade here. They are the spots where moving a piece from left to right will actually reduce. Do you see what I'm saying? Now when you look vertically, where is the most, let's call that yellow, blue, purple and strawberry. So let's draw a vertical line in fact. So here's my line. Where can I get the most strawberry, D? How many strawberry here?
2.
Strawberry? Only one strawberry, right? At B.
It's like 1, 2. Like
No. How many strawberry am I passing through?
Okay, 1.
1. What about now?
1.
1. Any here?
No.
What about now?
2.
2, 2, 2. What about now?
3.
No. So the most strawberry I can get anywhere on the graph is at this point. Yeah? That means those 3 tasks, K, M, and Q, must be running at that time period. But in addition to K, M, and Q, what other task is also running?
N.
And that gives us our lower bound. So we can say that the lower bound is 4 workers because from time 20 to 21 tasks K, M, N and Q will all be running, and that's one way we can do it without having to draw a scheduling diagram to find the minimum number of workers. Okay, so at that point there are 3 tasks running. 4 tasks running. The critical path and 3 other tasks. Any questions on that?
No.
Yeah, you follow that? Okay.
Yeah.
I know it's
So
a little bit tricky.
You have to calculate the times when they're all intersecting.
You have to look at the times where the line will cross through the critical path and other kind of strawberry areas, let's call them. Yeah? Okay, cool. Let's move on to question 3. Oh, algorithm. Okay, so we start, compute. Oh, this looks messy. All right, use the flowchart with A equals 1 to complete the table in the answer book. Work on values to 6 decimal places. Jeez Louise. Okay, I'm going to shrink this down a little bit so we can see both side by side. Let's move this over here. And move this over here. Okay. So, we start by inputting A. What's our A value? 1. Next, we calculate B.
is 0.967.
So we want it to 6 decimal places, so we should write it to more. So 0.967166821. That's just a little bit more decimal places. Now, is it between negative and positive 10 to the minus 5, a minus b? So you subtract the two of them.
A minus b is 0.03.
Okay, so it's not particularly small. We want that to be really, really small. So what we're saying is the difference between a and b, is it less than? Do you understand?
But it's in between minus
Yeah.
negative and positive, no? So this is negative 0.000.
Right. So if it's between here and negative of that, that's what we're looking for. And we got a value of 0.0343, right? That's outside of that range. So we're going to keep trying to, you can see what's going to happen. What do you think is going to happen? The difference between these two is going to get smaller and smaller each time. Okay? Now, if it's not, we change A into B, so we're moving B across here. So 0.967166821. We perform our calculation again, and we get 0.97278.9.34 is the difference between them. So do the subtraction. What'd you get? So using the memory function calculator, repeated calculators, or if you have a spreadsheet function or your graphic calculator, can make this a little bit easier.
It's hard to do things like this.
Okay. All right, so what do we get next? Still not, so we continue. And we can continue in the same fashion and we carry on down. And eventually you will get a b value, 1, 2, 3, 4, 5, 6. The sixth b value will be 0.971968880. When you move it over here, 0.971968880. And the corresponding b value you will calculate is 0.9719750, and when you subtract them, you get a value that is less than 1 times 10 to the minus 5. Hang on a minute. Okay. Given that the value of the input a is a non-negative real number, determine the set of values that a cannot be used to solve this problem. So this is a recurrence equation. If you multiply this by power of 4, you get b to the power of 4, right? If you multiply by 8, you get 8b to the 4 plus 5x minus 12. This is a rearrangement, a recurring iterative function version of this. So determine the set of values at a that cannot be used. Okay, so if you look at this, this function here is the fourth root. It's a root. What can't you find the root of? What gives you a maths error when you try and find the root?
Negative.
Negative. So what is our criteria?
That'll be greater than 0.
So when 12 minus 5a is less than 0, or 12 is less than 5a, or a is greater than 2.4. So when a is greater than 2.4, this function will not work because it cannot compute the root of a negative number. So we're using kind of like our pure maths in here, kind of surprise, pure maths, turns up everywhere. The final output should have got to 5 decimal places. is 0.97197. A relatively straightforward question, yeah? It's just computing power. You need to be accurate. It's not particularly hard. You just need to be careful. Oh, yeah, so you need to make sure you don't lose your calculator the week before your exams. Okie dokie. Let's get rid of that straight line again. Okay, question 4. Oh, look at that nice webby mess. Figure 4 models a network of roads. The length in kilometers. Vertices A, B, C, D, E, F, G are several towns. Derek needs to visit each town, so he's visiting each node. He will start and finish at A. What does start and finish at A imply? What do you need to do to the graph if you're starting at A and finishing at A?
I don't get the question.
When you're starting at and finishing at the same node, what do you need to make your graph?
Eulerian.
Yeah. You need to make it Eulerian, so you need to make every node what?
Even.
Even. Okay, so now we need to check for even nodes. Have a look at that graph, and without doing anything technical, how many odd nodes are there? Quick. 7 odd nodes. Wow.
How many nodes are there?
No, I said how many odd nodes are there?
2.
You sure?
C and
Can't be too careful. So we're gonna highlight our odd nodes because that's important. So C and what's the other one?
E.
C and E. Are there any other odd nodes? So let's just check. This is a valency of 4. This is a valency of
4.
This is a valency of
4.
Is it easy to make a mistake doing this?
Yes.
Yes.
6.
6
I was right.
and 2. Yay! Well
Yeah,
done. You were
right.
right. And we also know the total weight, so we don't need to actually add up the values that later on in the question, because we know that all of these nodes are 291. We need to make it Eulerian. That means we need to connect C and E. Does that mean we need to do a straight line connecting C and E?
No.
We want to find the what?
The shortest distance.
The shortest distance, right. If we go this way, then that's going to take us 29, right? And
Yes.
going direct is 19, so definitely not the 29 route. So what is the other route we can take?
E to F, then F to C.
So if we connect C to F and E to F, since we've added 2 nodes to F, F becomes 6, still even. C becomes 4, and E we've added 1 to it, so it becomes 3, 4, 5, 6. Now everything is even. Our graph is Eulerian. When a graph is Eulerian, you can start at any node and finish at the same node. So the fact that it starts at A, it doesn't matter. It could have been starting at D, finishing at D. It could have been starting at F, finishing at F. Does not matter. Once you've made it Eulerian, you can start and end at the same node. So by inspection, oh, hang on. They didn't even ask us to do that. Anyway, we got a little bit ahead of ourselves. By inspection, complete 2 copies of the table of least distances. Okay, so we have our table here. We need to complete the table. So we have some values missing. So we need to connect A and C. What distances are connecting A and C? What's our shortest distance?
No. 25 plus 19 is 44.
It's hard to see, right? Let's get rid of all that. So, what's A to C? Shortest distance? Lots of different options.
Yeah.
Do you think we're going to go 21, 29,
No.
21, 12, 21, 15? These are all bigger numbers. We're in the 30s and the 40s. If you can get something in the low 40s, we're probably good. What about this one? 17 plus 15
32.
plus 6 plus 11,
17.
which is
59.
49.
17 plus 25 plus 6 plus 11.
17 plus 15 plus 6 plus 11.
Yeah, 49.
Yeah. Okay, so we got under 50 there. Can we do better than that? The answer is yes. 17 and 15 to get to E. There's a shorter distance. You go straight to E. So that's 25. And then we can take 17 or 6 plus 11. Which one's shorter?
6 plus 11.
Okay, so what's 17 plus 25?
17 plus 25?
Yep.
42.
And that is the shortest route. What's the other route we need to determine?
C to D.
C to D. Let's hope that's less dramatic.
Yes.
So do we take the 19?
No, 11 plus 6.
We take 11 plus 6, that's shorter, right. So that's 17 plus 15 is?
32.
32 is correct. And finally, FD. So F's down here. FD, do we go 23 direct?
No. Wait, F is F?
F is here, sorry.
Okay.
Surprise. FD is what?
23.
No.
You can go from
Yeah, F to E,
and then E to
D, so that's 21. Okay, cool. Completed. By starting at A, use the nearest neighbor algorithm to find an upper bound for the length of Derek's route. So do you remember what nearest neighbor algorithm was? It's like Prim's, right?
Yes, but
It's a
instead
virus, but
focus only on that particular node.
no, it's very good. So we're starting where?
A.
Starting at A. So we're not okay. So we start at A. This is one. What's the smallest?
17.
17 is the smallest, so number 2 is D. Let's write it down. A, D. And what's the nearest now?
15. E.
Okay, so A to D was how far?
17.
17. Yeah, you see this is going to help us later. And at D, what's our smallest value?
15.
That's E. So ADE, so we write our 15 in between there. And cross off E. Now we're at E. What's our smallest value?
6.
6
F.
for F. Let me cross off F. That's number 4. What's the smallest value here?
11. C.
C, so that's number 5. C with the length of 11. Now we're here. Oh, we cross off C, yeah. So C can connect to 26 or 46. It's going to be 26 as B. So that's number 6. B with a length of 26. Notice by writing these numbers as we go along, it makes the next step a lot easier. And finally, we're going from B to G, which is a length of 20. So the total, can you add them up for me? 95. Okay, and where do we end?
A. Start
Where do we end?
Start at you end at
We
G.
A, we end at,
G.
but then we have to get back to.
A.
Okay, so what's the quickest way to get from G to A?
41.
You go back to from G to
B.
and then
then B to
BA.
A.
Ah, you see, you got to read the question carefully. And G to B we said was 20 and 21. So add those up, what you get?
136.
136. And checking the mark scheme there, we get the same answer, very good. Okay, next part C. Interpret the route found in B in terms of towns actually visited. Okay, what does that mean?
The towns we went to.
It's not this. This was the distances between, but not the actual towns visited. Do you understand?
Yeah.
The actual towns visited. If, like, for example, if I said FD was 21, what towns did I visit to get that 21? I didn't just go from F to D. I went from F to E.
Then E to B.
Okay, so let's look at our route and let's plan it out. Let's look at this. So we started at where? A. And then we went to D with a distance of 17. Is that direct?
Yes.
Okay, that's fine. Then we went to E. From D to E, distance of 15. Is that all right?
Yes.
That's direct. Now E to F, distance of?
6.
That is correct. Okay, F to C, distance of 11?
That's direct.
That is correct. See what's going on here? We're understanding what's going on. So, and then from C to B, did we go direct?
No, we didn't.
How do we go from C to B?
It's 26.
We got 26. How do we get 26? We went from, went from C to
E
to
to F.
and then F to,
To
so
B.
C to F, and then F to B. It's hard to spot that one, right? Because you're going in the wrong direction first. So C, F, B. So now we're at B. That's this B here. We then went to G. From B to G, did we go direct for 20?
Yes.
Yep. So we're at G. Now we're at G. We want to go to B again,
It's direct.
which is 20, and then B to A, direct 21. So almost the same as, but just a couple of extra nodes. Okay, start by deleting A, find a lower bound for the root. So let's look at this. So we're going to delete A.
Fill in
So we're going to delete A. Yeah? And we found a lower bound for the root. So where are we starting?
fill in the numbers of the did before.
Oh yeah. What numbers did we get? 32 and 21, right? Okay. Now what was the first node we started at after A? It was D, right?
Yes.
Well, we can start. Did it tell us?
Did it say?
Oh, okay, we start at B. So if
Can
you
I choose
start,
any one you want?
yeah, you should be the next one. So we start at B. What's our smallest value?
12 to E.
So E, so that's number 2. And what's our smallest value there?
6.
So let's get those.
How is it principal?
We need the root. So B to, it's nearest neighbor again.
Okay.
So B to E we said was 12. And the next one is 6, which is to F. So let me write these down. So we started at B, we connect to E, then we connect to F. Yeah?
Yes.
That's your 12, that's your 6. Now you're at F, what's your smallest number?
Cancel F. 11. C.
11, which is C. So that's number 4, so that's C, and that's plus 11. Can you see how I'm writing the numbers so you can see?
Yes.
Okay, so now we're cross out C. In C, what's our smallest number?
46.
Smallest number?
32.
32 to D. So that's number 5. That's D plus 32. And then from D, our smallest value is back to G, which is 47. Okay,
Yes.
what do we do now?
Then you go back to A and pick the least two numbers.
Okay, so if you're looking at A, what are the smallest numbers connected to A? 17, 25, 45, or 21?
17 and 21.
So AD and AB. So A connects to B and connects to D. AB is 21 and 17. Can we get a sum total?
Yes. 1 or 2.
1 or 2 kilometers. Very good. You happy with that?
Yes.
Okay, cool. And finally, part E. Clive needs to travel along the roads to check that they're in good repair. So now we're not looking at nodes, we're checking the roads. He wishes to minimize the total distance traveled. He must start at A and finish at G. So that comes to, remember I was talking before about odd and even nodes?
Yes.
So he must start at A and finish at G. That means what?
That'll be our 2 nodes.
It means starts at A and finish at G. Is A odd?
No.
Is G odd?
No.
So we need to make them odd. Because what are we making it?
Like
Semi-Eulerian.
similar. So 2
So we want
expands.
odd, even, odd. Okay. So we need to connect, to make the E and C, we need to make them
Odd. Even.
even, right?
Yes.
So our nodes are so if we did this, can you see how that would appear?
Make it.
Yeah? Also, if I did this, can you see how that would appear? Making these two even and these two odd.
Yes.
Or I could have connected A to C and G to E. Can you see how that would make me? So I need to explore all of these options to find the smallest. So my 4 nodes are A, C, E, and G. Okay? So the pairings, I could do A with C, A with E, and A with G. So A to C means E connects to G, A to E means C connects to G, and A to G means...
C connects with E.
So I need to find the shortest path between these. So AC plus EG is 42 plus 32. AE plus CG is 25 plus 46. And AG plus CE is?
Okay, using the table?
Yeah.
41 and 17.
41 and 17. Okay. So which of these is the smallest total?
The last one.
So we have 74, 71, and 58. So
Yeah.
therefore we want to connect A to G and C to E. But we might not be collecting them directly, remember? What is the shortest path between them? We might be going via another node. So we want AG plus CE. So if you want to go from A to G, what's the shortest path?
A to B, then B to G.
Yes. So the nodes we're adding are these. Because we're adding 2 nodes to B, it remains even. And E to C, what's the shortest path?
6 plus 11.
So E to
F, then F to C.
and F to C. So we're adding 4 extra arcs. We know our total weight is
58. 291.
291, and we're adding 4291. We're adding 41 from A to G and 17, which gives us 349 kilometers. Good work.
Yes.
All right. Okay, question 5. Figures as next rows, then the numbers on each arc represent the length in miles of the corresponding road. Tamasi, who lives at A, needs to collect a caravan. Tamasi can collect a caravan from either J or K. Tamasi decides to use Dijkstra's once to find the shortest A to J and between A and K. Which one should he choose?
Since
How do we find it out?
he wants to connect from A to J and then A to K, and both routes has A, so you choose A to start with.
Okay, so we're starting at A because that's our starting node and that's on both routes. And then we're looking at the shortest distance to each route. Yeah? What algorithm will tell you that? Which algorithm? Shortest distance to every node in the vertex from the starting point?
Nearest neighbor.
No.
Oh, Dijkstra.
Dijkstra, very good. Okay. Also, he uses Dijkstra's algorithms in the question. Okay, use Dijkstra to find the shortest route from A to J and A to K. Okay. So this is weird, this. Why is it weird? Why is it weird?
You have to keep reducing the
Where is our start node?
A.
Where is it geographically on our page?
Right.
Yeah, so normally when we're doing these, we start on the
From left.
left and work our way to the right. Here, we're starting in the top right and going backwards. What do we write in our start node?
1, 0.
Okay, so I'm going to do this quick. So this is 1, it has a strength of 0. 0 plus 12 is 12. 0 plus 84 is 84. 0 plus 24 is 24. 0 plus 32 is
32.
32. So remember, we've now used this node, this node, this node, and this node. As I'm working my way around, I'm going to circle all the nodes, because if there are any values that I don't circle, it means I've missed them, I've made a mistake.
Yes.
Eventually, every one of them should be circled. So 12, 84, 24, 32. Which one's smallest?
24. 12. I just 12.
Okay, so we're going up here. This is node number 2, which has a weighting of 12. Now, which new nodes get added?
11.
So 12 plus 39 is...
51.
So you see how this works, yeah? It's quite clever if you do with the circling. 12 plus 31 is...
43.
43. 12 plus 11 is...
24.
12 plus 11 is...
23.
Right. Have we connected all of our nodes from 12?
Yes.
Yeah, now can you see it's quite easily
Makes sense.
visually accessible. Now look at our nodes that we haven't. And what I'm going to do is every node that I have, I'm just going to... Oh my god, that's horrible. Let's go with yellow. I'm going to shade it in so we know that we don't need to consider those. Okay, so what's our smallest working value? 51, 84, 43, 24, 23, 23. So that's node number 3 with a weight of 23. So that is now added to our network. Okay, so what are we going to do? 23 plus 8 is 31. 23 plus 20 is
43.
23 plus 32 is
55.
23 plus 69 is
92.
Is that all of the nodes from D?
No. 23 plus 17.
Yeah, look at you. Yeah, for not falling for the traps, are you? 23 plus 17 is 40. Now, looking at all of our red values, which is the smallest? Be careful, it's easy to make a mistake here.
G. Wait. B. 31.
31. So that's number 4. 31. So we highlight. And we connect. How many new nodes is that going to give us? How many new paths? How many new paths? It's going to give us 31 plus 10, which is...
40.
Is that it?
No, and then...
There's the 18 up here, right? You can see it not highlighted, so you can see. So 31 plus 18?
49.
49. Circle the 18. It's done. We good?
Yes.
So what's our smallest value?
40G.
G. So that's going to be node number 5 with a weight of 40. So let's work our way clockwise. 40 plus 8.
48.
40 plus 42.
82.
40 plus 49.
89.
89. 40 plus 17.
We can't do that because there's...
Oh no, we should have said it before.
Yeah.
Yeah. See, now we can easily spot that. Okay, what's next? That gets added to the network. Look at the non-yellow ones. Which one has the smallest number? We've got a 48 up here. We've got a 41 down here, right?
41.
So this is going to be node number 6.
And 41.
So let's yellow it. How many new paths does that add? There are 3 paths out of E. 2 of them are already
So
circled.
one more remaining.
So it's just one more. 41 plus 10.
51.
Okay, so looking at the remainder, we have 48 up here.
So
80,
F,
80, 51.
F
So
would
it's
be the
going to be
next
F,
one.
yeah.
7.
7, 48. How many new paths does that add?
One more.
One more, because everything else is circled.
Yeah.
So 48 plus 32.
80.
Oh, that gives us a cheaper way. Okay, so that's 80. Right, we only have 3 nodes left. Which one's the cheapest?
H 51.
So that's going to be 8, 51. I should have highlighted that. So 51 plus 30. 51 plus 30 is 81. Okay, so now we have an 80 for J and an 81 for K. So which one's next?
J
J
980.
980. And no new nodes, no new paths added. And this is going to be 1081. Awesome. All done?
Yes.
Okay, cool. Next. That was easy, right? Say the root current. So we want A to J. So A to J, if you were going from A to J, what's the length of the path? That is
80.
80, right?
Yes.
What's the distance from A to K?
81.
81. So what path would you take?
You start from backwards. So you, starting from J.
No. Well, starting from J going backwards, yeah.
From J to F. That's one.
From J to F,
Then F to G.
because 80 minus 32 is 48. Then
F-
48 minus 39, 12, no, 48 minus 18.
No, F to G.
F to G,
48 minus 8 is 40.
yep, and 40 minus 17 is 23.
Yes, D.
23 minus 11
Yeah, give it 12.
is 12,
Then C to A.
and 12 to A. So our path from A to J is A to C to D to G to F to J. And do the same for K. You get A, C, D, A, C, D, B, E, H, K. Okay, and this one was 80 miles. This is 81 miles. Okay. That's busy. 9 marks out of 10. Only one more to do. Tomasi's brother, Rolo Tomasi, I think his name is. Tomasi's brother lives in F. He needs to visit Tomasi at A and then visit their mother who lives at H. Find the route of minimal length that goes from F to H via A. F to H via A. What are we really asking?
Trying to find the root. That
Right, we
includes
want
H.
to go to F to A to H, right? But what's the shortest distance from F to A?
I don't know, sir.
Yeah, you do. We this
Or
is
you
on.
figure it out using
Yeah,
extra.
we've already got that.
Okay, that's right.
So what's the path from shortest distance from F to A? We're going from F to. No, it's there. Follow the path. It's already on that critical
F
path.
to G,
F to G to
D,
D
to
to C to
Oh.
A. Now we want to go from A to
to H.
H. So what's that?
Zero.
How do we get? So let's work our way backwards for this as well. Does that, yeah? You see what I mean? You're splitting it in two. So 51 minus 10, 41.
Yeah.
41 minus 10, 31. Then 31 minus 32, 0.
No.
31 minus
Minus
8. And then to there, and then to there. All right. Okay, so let's write that down. From A, we then go to, follow the green path now,
Yeah.
to C,
We go forward now.
to
Yeah,
D,
to B, to E, then to H. So if we from
you've
F,
done half the work already. Yeah, from F to A, because if you're going, because both of those nodes were not part of Dijkstra's start point, there was no A. You haven't got the calculations for it, but because we have to go via A, we can just reverse Dijkstra, because F to A is A to F.
Yeah, think of that.
Yeah,
Yeah, makes sense.
cool. Ooh, right, we've got 2 questions left, and this one's a doozy. Right. Should we do it? You ready? Okay. So there's going to be lots of erasing as we're working along. As we're writing this, we're writing this with pencils. It's okay to write it kind of lightly because you are going to be erasing and you don't want to mess things up along the way. Okay, so we have no proceedings on A, B, and C. So for now, we can write A, B, C. Okay, let's tick them off as we're working through them. D and E both both require A. D and E, do they come up again?
Yeah.
They both are required by E. So I know that I'm going to need D and I'm going to need E, but I'm also going to need a dummy. Yeah? So I can read ahead and see that that's going to happen. Okay. So D requires A done, E requires A done, F requires A, B, and C. So I'm going to put B up here and another dummy there, B and C. Okay. Does F come up again?
No. Yes, and for I.
In the same one, the one that requires D and E. So now I know I can connect my F this way. You see, reading ahead makes it significantly easier to draw. Okay, G requires C.
Yeah, and it doesn't come up.
And it doesn't come up again. So my sync node over here, yeah?
Yeah. It comes up again for
Oh,
H.
it does come up. H requires it.
Yeah.
And H is needed here.
Yeah.
So I can put my G here, and then I put my H here. And now I have D, E, F, and H.
So I is complete.
So I've got G, I've got H, and I've got I ready, yeah?
Yeah.
So I, does it have a prerequisite?
Yes, J and
It has
K.
3 prerequisites.
And L.
So I'm going to put my I here. And now I need J, K, and L all coming from it, but L also needs to,
Connect to M.
okay. And we also need to go to our sync node. So we're going to have J, K, so that should be that, L, and L also needs to lead to
M to the sync.
M, and then J needs to head back to the sync node via
Dummy.
dummy. So we've done that with 1, 2, 3, 4 dummies. Draw the activity using activity on arc and minimum number of dummies. So I think 4 dummies is pretty fine for that. Which activity is guaranteed to be critical? Well, is there any activity that is compulsory for every path from start to sync?
What compulsory?
Is there any activity that, if you made it longer, would make the whole task longer? Yeah. Yeah?
The longest path.
So it's not just the longest path, it's the fact that everything goes through I. No matter where you're going, if you're starting here at your start node and you're ending at your sync node, there is no way to get to the sync node that isn't going through I. Yeah? Every path leads through I. So it's like every path to university leads through the A-levels. If you took 3 years on your A-levels, that's going to take you longer. If there was another way to university, let's say you did BTECs in 2 years, then you don't pay the 3 years, right? But if the only path was the 3, yeah? Okay. State which activity is guaranteed to be critical, so that's I, because it's on every path. It is given that each activity takes 2 hours to complete, so you're going to be looking at that. State the minimum completion time. So do you want to find the shortest path or the longest path?
What's the question again?
Every activity takes 2 hours.
Yes.
Do you want the shortest path or the longest path?
The longest path.
Let's say we have 2 people. One person takes 6 hours to complete their task.
Yeah.
One person takes 8 hours to complete their task.
Yes.
How long will it take for both of them to be finished?
8.
8. You go
Yeah.
by the longest path. So you're trying to find the path through here that is the longest. So the most number of letters. Okay. So let's do this in stages. If we were here at the end of I, what are the different ways to the sync node? We can go via J,
K.
we could go via K, or we could go via
L.
L and M. So that's 2 paths. So that's 1, 2. So that's going to be our critical path. Part of it, yeah? What's the longest way from the end of I to the start of I? It's just that.
So L is 2, M is 2.
M is 2, I is 2. So far this will take 6 hours. If the person going this way will only take 4 hours,
Yes.
but you're still waiting for that to finish. So what's the most number of letters I can get from the start of I to the start node? I can go DA,
Yeah.
I can go E,
A.
I can go
F,
F,
B,
A, I can go F,
B,
B, I can go F,
C,
C, I can go
H, G, C. That's a smart man.
You see, when you understand it, it's not that hard. So, how many hours is that?
2, 1, 2, 3, 4, 5,
2,
6.
4,
So
6,
times 2, 12.
8, 10, 12 hours. Easy peasy. That's why it's only 2 marks. But again, it's comprehension,
Very
right? When you
critical.
understand it,
I have to think.
straightforward. Okay, ready? Last question. What is this? This isn't supposed to be pure maths.
So confusing.
Okie dokie. Right.
Oh, I didn't do that question.
We have another guest here for the video. Yeah, we're making a video. Right, okay. Figure 5 shows a weighted graph that contains 12 arcs. Do you want to come over this side so you can see?
Yeah.
So figure 5 shows a weighted graph that contains 12 arcs and 8 vertices. Oh geez. It's given that no two arcs have the same weight. Oh, that's interesting. No two arcs have the same weight. That's that kind of thing that if we forget about it, it's going to come on bite us later on, right? Okay, so we've got to remember that. X and Y are positive integers. Okay, so that tells us some basic stuff, like, for example, what must Y be?
Maybe more than 2. More than 1, yes.
More than 1,
Yeah.
right. Yeah? Arc CD is not the minimum spanning tree. So CD is not on the minimum spanning tree. Explain why Y is less than X plus 7. Okay, so remember what the minimum spanning tree is. It's a tree that
Connects to
has
node.
every node, but there's no cycles.
Yes.
Okay, so what should I do here? So if we say this is not on the minimum spanning tree, what is that really telling us? What's the only way to get to D now?
B. From A
From A to D. So therefore 3y minus 7 must be on the minimum spanning tree.
Yes.
But that also gives us some other thing. What does it tell you about these two paths? When you're picking the minimum spanning tree and you have two paths, how do you choose which one?
You take the smallest.
And so, what do we know? What do we know about those two expressions now?
So
If we
AD
chose AD and not CD, then
AD is smaller than C.
3y minus 7 must be smaller than 2y plus x. Can you guess what that's going to simplify to?
Y is less than X plus 7.
Well, let's do it. Move the 2y on that side. We get y minus 7 is less than x, or y is less than x plus 7. Again, looks harder than what it is, but you have to understand what it means. You follow that?
Yeah.
Okay. It's also given that when Prim's algorithm starting at A is applied to the weighted graph, AB is the first arc selected. What does that mean?
It's the smallest.
AB must be the smallest, right?
Yeah.
Okay.
That's so.
So what is AB?
4x plus 1.
Okay, so if that is picked, and that's the smallest, then what does that tell you about that relationship with this?
This is greater than this.
Okay, so do you see what we're doing now?
Makes sense now.
So 2y plus 1 is bigger than,
3y minus 7.
is bigger than, no, 4x plus 1. We're told this is the smallest.
Yes.
Yep. 2y plus 1 is bigger than 4x plus 1. 8x minus 3 is bigger than, oh, this one's getting interesting. Why is this one interesting? Because there is no what?
Y. There's no
So
Y,
we
yeah.
can actually use that to find a constraint on x.
Yes.
So 2y plus 1, 3y minus 7, same.
So 3y
3y
minus 7
minus 7.
is greater than 4x plus 1.
It's greater than 4x plus 1. Now if you simplify these down, minus 1 from both sides, divide by 2, we get the inequality y is greater than 2x.
Yes.
If we simplify these, we get 4x is greater than 4, or x is greater than 1. And there, that's 8, and therefore what we get here, we get 3y is greater than
4x
x plus 8. We started doing one kind of a question, but which kind of a question does it look like it's heading into? what do we have here?
Inequality.
And therefore, what do you think we're going to be doing?
Chapter 7.
Yeah, linear programming.
Yes.
Yeah.
Once we're going to draw those graphs, what do we know? What's that first thing we forgot? No two have the same way, and
X and Y are
positive integers.
Yeah.
So therefore, since they're integers, what are we going to do to decimal solutions?
You gotta increase.
Disregard them. We're not looking at, we only want to find integer solutions within our region. Okay? Hang on. Go back. Yeah, so that's the constraint, that's B. Okay, represent these 4 constraints on a diagram in the book. Okay, so we know x is bigger than 1. That's an easy one. Let's do that one first. Is that right? Nope, it's there.
Yes.
So I'm going to make these a nice color. What color should we go for? Purple?
Blue.
Blue. Ah, why so blue? Feeling a bit down? Right, x is bigger than 1, so what do we disregard? Bigger or smaller? What do we shade in?
The left side.
Yeah. Okay, first one done. Next one. Y is less than x plus 7, so we draw y equals x plus 7.
So
Also, are these inequalities equals?
no, so it's dotted.
So they're dotted lines. So we have to remember that. No, I'm going to draw them as full lines, but you remember that on the line solutions will not count. Yeah?
Yes.
So if I go, that's not a blue line, is it?
No.
Let's try that again. So intercepts at 7. If we went 6 right, that means we'll go 6 up. Because the gradient is 1. Y equals
Yes.
x plus 7, yeah? So if we went 10 right,
10.
we are going 10 up. So 10 up is 17.
They can also use when x is 0 and when y is 0, yes.
Huh?
You can also use when x is 0 and then when y is 0 to get the points.
You get the first point when, yeah. Okay. Y is less than or greater than?
Less than.
So we shade,
Above.
yeah.
Yes. Above it.
Expert shading. Yeah, I've been working on my art recently. Okay. Okay, next one. Y is greater than 2x. So it crosses the intercept. Crosses the origin. But when x is 10, what's y?
Where is it?
Y equals 2x.
Okay, so when x is 10, y is 20.
When
It's
x,
5.
when x is 10, 2x, y is
20.
20. Okay. Do we want y is bigger, so we shade
Right.
yeah
It's right.
below.
Yeah, below.
So that's so our solution area is closing in quite nicely. Not many integer solutions. Finally, 3y is 4x plus 8. Ooh, that's a bit messy. So let's put some values in. When y equals 0, what's x? Minus a half. No, that's not good. Minus 2.
Yeah.
When y equals 0, x equals minus 2. That's somewhere over here. When x equals 0, y is
8 over 3.
when x equals 0, y is 8 over 3, which is 8 over 3, which is 2 2/3.
Yes.
So that's about here. Yeah? When x equals 1, what's y? Oh, that's a good one. What's when x equals 1, what's y?
4.
4. So let's try when x equals 3, 4, 4. When x equals 4, 8. Yeah? 24 divided by 3, 8. So if we did 1 and 4, what would be the next easy one to plot?
8.
What are we going up
4,
in?
3.
We're going up in
4,
3
7.
because this is the 3 times
Yes,
table,
7.
yeah?
Yeah.
So what's 4 times 7? You can do it. 4 times 7.
8, 30, 20, 24, 28, 32.
4 times 7 is 28. Plus 8 is 36. 36 divided by 3 is 12. So when you're at 7, the height is going to be 12. Okay? So we've plotted our points. Let's draw our line. And that's all we need for our region. Do we want y is above, so we shade below. Right, now we've got some integer marking to do. So let's zoom right in on this. Now, we see where our integers are, right? So let's dot our integers. Can we pick a point on the line?
Yes.
What did we say about the lines?
It has to be.
Are the equations equals?
Yes. No, you can't put that.
You
'cause it's
can't pick
dotted.
any points on the line,
Yes.
so we're only picking in the region. So can x equals 1 at any point?
No.
All right, let's go up in x equals 2. So 2, 3, 4, 5, 6,
Yes.
7,
Yes.
8,
Yes.
9.
No.
3, let's go up in 3. Do you see how we're doing this? So 3, 6,
No.
3, 7,
Yes.
3, 8,
Yes.
3, 9,
Yes.
3, 10.
No.
Okay. Let's go up in 4s. 4, 8
No.
on the line. 4, 9,
Yes.
4, 10,
Yes.
4, 11,
No. It's up. It's
and
above it.
5, 5, 8, 5, 9,
No.
5, 10,
No.
5, 10.
It's on the line. Yes.
I think that 5, 10's on the line. There. 5, 11 is not on the line.
There. Down there.
And 5, 12 is on the line. So that gives us our 3, 6, 7, 8, 9. Only 9 solutions. Okay? Okay. Write down the possible pairs of values that x and y can take in the form. So what shall we call? They are,
Okay, so you just pick.
yeah, it's just 2, 2, 6, 2, 7, 2, 8, 3, 7.
But if they're on the line and it was not dotted, you can add
It doesn't matter if it's on any dotted line. If it's on a full line and a dotted line, we don't allow it. Four, 9, 4, 10, and 5, 11. Okay. Constraints represented. Write down the integer solutions. Now we're going to link it back to our question. The minimum spanning tree for the weighted graph in figure 5 has a total weight of 73. 6 of the 7 arcs in the minimum spanning tree are A, B, A, D, B, C, E, F, and G, H.
Yeah.
Okay,
Yeah.
so let's add those arcs first.
A, B,
A, B,
A, D,
A, D,
B, C,
B, C,
C, E,
C, E,
E, F,
E, F,
and G, H.
and G, H. So really, what are the nodes we're comparing?
Trying to connect.
So what are the only ways that we can connect to
E-
make sure our graph is connected?
EH. Wait.
The only ways we connect are EH and FG.
Yes.
And we want to know which one
The
is
smallest.
smaller, right?
Yeah.
So we have EH, which is 5x plus 1, and FG, which is 5x plus 1,
And EHY plus.
and the EH is y plus 1. Determine the value of x and the value of y. Go back to the question. No two arcs have the same weight. X and y are positive integers. Yeah? Okay. So, how do we do this?
Do you plug in all the values?
Five x plus 1 and y plus 1. Okay. So let's map these. What's 5x plus 1?
11.
11.
Yes.
And what's y plus 1?
7.
5x plus 1, 11, 8.
Yeah.
And then we have 11, 9. Oh, you see what's happening here?
Yes.
5x plus 1, 15, 8, 15, 9, 15, 10, 20,
So 5x plus
21, sorry. Oh, sorry,
That
this
was
was 16, yeah.
yes.
Man. All corrected. So 21, 9 plus 1,
10, 21,
21,
11,
11, and
26,
26,
12.
12. What do you notice about all of these? Which is bigger? The x value or the y value?
The x.
So in every case, y plus 1 is smaller.
Yeah.
How do we choose which path to add when we're connecting to the minimum spanning tree?
The smallest.
So therefore, by that logic, EH is our minimum spanning tree. Because in every one of our potential solutions,
Oh, I can see it.
5x plus 1 is bigger than y
Yes.
plus 1.
Yes. But we're looking for the smallest.
And we're picking the smallest because we find the minimum spanning
Yeah,
tree,
that's
right?
That's one.
So go back, determine the value of x and the value of y.
The spanning tree is 73, has width of 73.
Okay. Now, we are also given one other piece of information. Oh no, we can find the total weight. The total weight is
73.
73. So that means if we add
Add all
all
the-
of these,
Yeah.
we should get a number of x and a number of y. So how many x's do we have? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14x. We have 3, 4, 5, 6, 7, minus 2 plus 5y.
We have 5y.
And then our numbers are minus 7 plus 1 is minus 6, minus 8, plus 1 is minus 7,
Yes.
plus 3 is minus 4. And we know that that's equal to 73. Okay, so what do we do now?
You equate it.
We got 14x plus 5y is 77. How do we solve?
Using one of the values.
14x plus 5y is 77. 14x plus 5y. We know one of these is our solution. We want to know which one of them will give us the answer 77. Does that make sense?
Yeah.
So, which one did you get?
3 and 7.
3 and 7. So it's a bit of trial and error. That's why it's worth 4 marks. It's not particularly hard, but there's a little bit of calculation going on. So you need to understand what's going on. And well done. That takes us to the end of the paper. Hopefully you found that useful.